5.4, Sum and Difference Identities for Sine and Tangent. We talked about in 5.3 the sum and difference identities of cosine, and I explained why we have to have a sum and difference identity. So it's for the same reason we have to have sum and difference identities for sine and tangent. The sum and difference identities for sine are sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. Sine of a minus b is the sine of a times the cosine of b minus the cosine of a times the sine of b. So both of these are the same except for the signs in the middle, and unlike cosine, if it's plus here, then it's plus here. If it's minus here, then it's minus here. And then the sum and difference identities for tangent are tangent of a plus b is equal to tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. And then the difference identity is the same except for the signs. So just like we did with the cosine sum and difference identities, we're going to find values that would give us the angle that we're looking for, that are angles that we know the values of from the unit circle. So for this first example, to find the sine of 15, and again, whatever values I pick, you don't have to use those values. If you have some other values from the unit circle that will give you the angle that you're looking for, you can use those and you'll get the same answer. So for the sine of 15, I can get that by subtracting 30 from 45. So those are the angles that I'm going to use. I'm going to say that this is the same thing as the sine of 45 degrees minus 30 degrees. Now, the difference identity for sine is the sine of a, which in this case is 45 degrees, times the cosine of b, which in this case is 30 degrees, minus the sine, or the cosine of, let me write that again, sorry. The cosine of a, which is 45 degrees, times the sine of b, which is 30 degrees. Okay, so this was my A and this was my B. All right, now we're going to replace those with their values. The sine of 45 degrees is the square root of 2 over 2, and the cosine of 30 degrees is the square root of 3 over 2. Minus the cosine of 45 degrees, which is the square root of 2 over 2, times the sine of 30 degrees, which is 1/2. I multiply those together and I get the square root of 6 over 4 minus the square root of 2 over 4. And I'll put those together and I get the square root of 6 minus the square root of 2 over 4. All right, now for the tangent of negative 105. All right, so I am going to use these values. I'm going to say that negative 105 is the same thing as negative 60 plus negative 45. So I'm going to do a sum identity for tangent. The tangent of negative 60 degrees plus negative 45 degrees. All right, and the tangent identity, the sum identity for tangent is the tangent of A, which in this case is negative 60 degrees, plus the tangent of B, which is negative 45 degrees, over 1 minus the tangent of A times the tangent of b. All right, let's replace those with their values. So for tangent of negative 60 degrees, we would get negative square root of 3, and the tangent of negative 45 degrees would be negative 1. These are in the fourth quadrant. All right, so only cosine is positive in the fourth quadrant because this is negative 60 and negative 45, so you have to take that into account. All right, in the denominator, 1 minus the tangent of negative 60 degrees, so that would be 1 minus negative square root of 3 times negative 1, which is the tangent of negative 45. Okay, so let's simplify that a little bit. Let's see. That would give me negative square root of 3 minus 1 over, if I multiply these two together, that becomes positive, but it's 1 minus, so 1 minus the square root of 3. All right, this is going to, well, I didn't leave myself enough room. All right, so let's transfer this over, because this is not done. We can't leave a radical in the denominator, if you'll remember. So I have to rationalize that denominator. All right, so I do that by multiplying by the complex conjugate, well, not the complex conjugate, just the conjugate of the denominator. All right, so that would be, so I have 1 minus the square root of 3, so I'm going to multiply times 1 plus the square root of 3, both the numerator and the denominator. Okay, so if I do that, these are binomials. That would give me a negative square root 3. These two right here, that's negative square root of 3. Negative square root of 3 times positive square root of 3 would give me a negative 3. Negative 1 times 1 is minus 1. And then that would be a negative square root 3. All right, in the denominator, I would, again, FOIL, so 1 times 1 is 1. 1 times square root of 3 is square root of 3. Negative square root of 3 times 1 is negative square root of 3. And negative square root of 3 times positive square root of 3 would just be negative 3. All right, so we did that so that it would cancel out all the radicals in the denominator. And now I'm just going to combine like terms. All right, so in the numerator, negative 3 minus 1, that would be negative 4. And then negative square root of 3 and negative square root of 3 would be negative 2 square root 3. That's over 1 minus 3, which is negative 2. So if I reduce everything by 2, divide both terms on top by that negative 2 on the bottom, that would give me 2 plus the square root of 3. Yeah, tangent's always a fun one to do. All right, let's see. Okay, in this next example, we're going to go backwards. So we're using the sine sum identity. All right, so that tells me that I'm just going to be adding, well, I'm trying to erase. We're going to be adding these two together. All right, so this would be the same thing as the sine of these two angles, 2 pi over 9 plus 5 pi over 18. Well, of course, I need a common denominator. So my least common denominator is 18. That means I need to multiply the 2 pi over 9, both the numerator and the denominator, times 2. So I would get 4 pi over 18 plus 5 pi over 18, which would give me 9 pi over 18. And that just reduces to pi over 2. All right, and we know that sine of pi over 2 is 1. All right, for the tangent identity, tangent is like sine in that whatever this is, it's the same sign as what we're trying to find. So we're going to be subtracting this time our tangent values. So this would be the same thing as the tangent of 80 degrees minus negative 55 degrees. Okay, so of course, minus and negative would be the same thing as plus. So this is the tangent of 80 plus 55 degrees, which would be the tangent of 135 degrees. And the tangent of 135 degrees is negative 1. All right, now let's simplify these expressions. So we're going to rewrite these using the identities. So this would be, again, this is my A and this is my B. So using the difference identity for sine, we would write this as the sine of pi over 4 times the cosine of x minus the cosine of pi over 4 times the sine of x. All right, so if we replace these angles with their values, sine of pi over 4 is the square root of 2 over 2 times the cosine of x. And then the cosine of pi over 4 is also square root of 2 over 2 times the sine of x. And then all we could do, we could leave it like that, or we could factor out that like term of square root of 2 over 2 and write it this way. Or if you wanted to write it like this, square root of 2 times the cosine of x minus square root of 2 times the sine of x, since they have a common denominator, over 2, and make it one term, you could write it like that also. All right, let's simplify the tangent of pi minus theta. Okay, so this is the difference identity for tangent. So this would be the tangent of pi minus the tangent of theta over 1 plus tangent of pi times the tangent of theta. Okay, so you know theta is just a variable. So we can replace tangent of pi with 0. The tangent of pi is 0 minus tangent of theta over 1 plus 0 times the tangent of theta. Okay, so 0 times tangent down here, that turns to 0. And we can just get rid of that 0 in the numerator. So we have a negative tangent of theta over 1, which would just be a negative tangent of theta. All right, suppose that cosine of s is 3 over 5 and tangent of t is 5 over 13. And angles s and t are in quadrant 1. They want us to find sine of s plus t. So we're going to have to find, we have cosine of s, we need cosine of t, and we have sine of t, we need cosine of t. So as I did in the video about the sum and difference identities for cosine, you can use either the Pythagorean theorem or the Pythagorean identity. I think it's a little easier to use the Pythagorean identity, so that's what I'm going to do here to find these other angle values. All right, so for angle S, we have cosine, and remember the Pythagorean identity. Let me just rewrite it here just in case you don't remember. is, well, I guess I'll write it down here, is sine squared theta plus cosine squared theta equals 1. Okay, so that's what we're going to do. We'll just leave it red. That's what we're going to do here. So sine squared theta plus cosine, which is 3 over 5, squared equals 1. So sine squared theta plus 9 over 25 equals 1, which I'm going to change to 25 over 25. And then subtract 9 over 25 from both sides. And that gives me sine squared theta is equal to 16 over 25. And then I'm going to take the square root of both sides. And I get that sine of theta is equal to 4 over 5. Okay, now we're in the first quadrant, so we know that it's positive. Oops. You could have also done that one really easily, just because if you know your Pythagorean triples, like the 3, 4, 5 triangle, you could get that one really easily. In the other one, we see that we have the sine of t is 5 over 13. There's another Pythagorean triple that is 5, 12, 13. So if you know those, then you would be able to get those angles really quickly. But I'm going to pretend like you don't know those, and I'm going to go ahead and do the Pythagorean identity to find the cosine of t. Okay, so again, sine squared theta plus cosine squared theta equals 1. All right, so if I have the sine of t, which is 5 over 13, squared plus cosine squared theta equals 1. Well, when I square these, I get 25 over 13 squared, which is 169. Okay, and again, I have to have a common denominator, so I'm going to do 169 over 169. And that leaves me with cosine squared theta is equal to 169 over 169 minus 25 over 169. So that gives me cosine squared theta is 144 over 169, and then I'm going to take the square root of both sides. Again, we know that it's positive because we're in the first quadrant, and cosine of theta would be 12 over 13. Okay, not theta. So this whole time I've been doing theta. So this would be cosine of t, and the other one would be the sine of s. Okay, so now we have all the parts that we need to be able to do our sum and difference identities. Okay, so for the sine of s plus t, so remember that would be sine of s times the cosine of t plus the cosine of s times the sine of t. All right, sine of s is 4/5, and then cosine of t is 12 over 13, plus the cosine of s, which is 3 over 5, times the sine of t, which is 5 over 13. All right, so if I multiply those, I get 48 over 65 plus 15 over 65, And I'm going to add those together, and I get 63 over 65. All right, they also want us to find the tangent of s plus t. Okay, so we already have the different values. Let me just rewrite them down here. So we have cosine of s, which is 3 over 5. Cosine of t is, let me go back up and see what that is. Cosine of t is 12 over 13. Sine of s is 4 over 5. And the sine of t is 5 over 13. Okay, so for this tangent, the sum identity for tangent is the tangent of a, well, in this case s, plus the tangent of t over 1 minus the tangent of s times the tangent of t. Okay, so we have sine and cosine of everything. We need to find tangent. So remember, tangent is sine over cosine. So that would mean that tangent of s, okay, so we're looking at these right here, would be sine over cosine, which is 4/5 over 3/5. So we would just take that and multiply by the reciprocal, and that would give me, the 5's would cancel, and the tangent of s would be 4 over 3. All right, so then for the tangent of t, we're going to do the same thing with these values. So I have the tangent of t, sine over cosine, so that would be 5 over 13, and then divided by 12 over 13, so it's going to end up the same where the 13's cancel out, so it would just be 5 over 12. Okay, so those are our tangent values that we need, and we're just going to plug them back into this sum identity. Okay, so we have tangent of s, which is 4/3, plus tangent of t, which is 5 over 12, over 1 minus tangent of s times the tangent of t. Okay, now I have to have a common denominator to be able to add these together, so my least common denominator is 12. If I multiply both the numerator and the denominator of 4/3 times 4, I get 16 over 12 plus 5 over 12. And then I can multiply these two, and that would give me 20 over 36. Okay, so then if I add the numerators, I get 21 over 12. And then down here, I need to get a common denominator, so I'm going to change this 1 to 36 over 36. And if I subtract those, then I get 16 over 36. And then I'm going to do just like I did earlier. I'm going to take the numerator And we can't divide a fraction by a fraction, so we multiply by the reciprocal. So that would give me 21 over 12 times 36 over 16. All right. Well, 12 will go into 36 3 times. And so that gives me 63 over 16 for my solution.